Hey grade 8s, welcome to math. It's Friday, almost the weekend. If you haven't done Thursdays or Wednesdays yet, go back and do that first. We're building in a sequence here, in order, so make sure you do one thing before you do the next. Today we're going to focus on surface area of cylinders. Now we've done it before, and most of you are really good with volume. You know how to do the volume of a cylinder. You get the surface area of one of the circles, multiplied by height. So, 3.14 times 8 times 8 times this, and that's the volume, and that's it for volume. It's really important that you understand the difference between the two, and actually put a little statement on our practice quiz we're going to do today. Just practice. The difference between surface area and volume. The surface area of something is how many squares will fit on a flat surface, right? How many squares? That's why it's centimeter squared. So they could be little 1 by 1 square centimeters, or meter squared, 1 meter by 1 meter, or kilometer squared, 1 kilometer by 1. But how many squares will fit on a flat surface? Okay? And we'll get to that in just a minute, because this is a curved surface if it's a cylinder. Volume is different. It's how many cubes will fit inside that shape. So you need a three-dimensional type shape. And how many of these 1 centimeter by 1 centimeter by 1 centimeter cubes, or 1 meter by 1 meter by 1 meter cube, or 1 kilometer by 1 kilometer by 1 kilometer cube? So the difference is the surface area is how many squares will fit on a flat surface. Like, we could figure out the surface area of this whiteboard, right? We could figure out the volume of this room, what's inside, the area inside, the space inside, that's volume, okay? So what I want to do is get the surface area of this cylinder right here. We have all the dimensions we need. Remember this though. I'm going to try to take out the little creation I did in my arts and craft time last week. This cylinder, it's kind of the shape of a pop can or soup can or whatever the case may be, and you can see that it's made up of 2 circles and actually a rectangle. If I were to cut the cylinder right there and open it up, it makes a rectangle. And the length of this rectangle, this dimension right here, or the base of it all the way along the bottom, that is exactly the circumference of that circle. So we need to do the circumference of the circle, right? Circumference is like the perimeter, the distance around. We need the circumference of that circle, and when we calculate that, that is the length of this, right? And I'll show you what that looks like. This is called a net, and some of you are struggling with nets, some of you are not. The reason we draw a net is to get the surface area. Remember I said it's the flat surface, so we have to make a flat object. We take a 3D object and make it 2-dimensional. So we need how many squares will fit on this rectangle, that's the distance around our can, and how many squares would fit on each one of those circles, that's the surface area of the top. So we do it in a few different steps. The first thing I'm going to do is the simplest part, I think it is the area of the top. And that is pi times radius squared, right? 3.14 times the radius, which is 8, times the radius again, which is 8. And I was looking at the answer key today. I have a different answer key, and I'll post this online as well for you. And the amounts were off by a little bit. And that is because we are using 3.14 for pi, and you know that pi is 3.1415927, kind of goes on and on and on. So if you use the button on your calculator, you'll get a slightly different answer here. So if your answer is within 1 centimeter or 1 centimeter squared or cubed, I'm sure it's fine, right? As long as it's really close. So that is the surface area of this, of one end. And you can see that in this shape, when we take it apart, we have 2 of these circles, 1 on each end. So I need to multiply this by 2 to get the area of the top and bottom of our cylinder. And when I multiply that by 2, I get 401.92 centimeters squared. Now that's the area of the end of our pop can. Now I need the rectangle in the middle. And remember, the distance around the circle, right? The distance around this circle, when we open it up, that is going to be the length of our rectangle. So the circumference is the distance across this rectangle. Now this rectangle is 20 centimeters tall, right, when we take it apart, but the distance around, like this circle, right, if we took this circle and opened it up, it would be the circumference, that would be the length. So I need to calculate the circumference, and that is pi times diameter. 3.14 times the diameter, well, if the radius is 8, that's halfway across, that means the diameter is 16. So when I multiply these two things, I wrote it down here for myself, I get 50.24 centimeters. Now that's the base, that's the distance all the way across. And you know that the area of this is a base times height. So The base is 50 times the height of 20. Okay, and when I multiply those two together, I get the area of this rectangle, which is, let me see here, 50.24 times 20, 1004 decimal 8 centimeters squared. So now, it's been lots of steps, I realize that, but once you do a few of these, it clears up. Or watch this video several times, okay? So, area of the circles, both of the circles, right, was this, okay? When I took this apart, if I cut this right here, open it up, I get a rectangle. The area of my rectangle is this. So the total surface area on the outside of the cylinder is this 401 plus this here. So if I combine these two together, if I add them together, I get 1406 decimal 72 centimeters squared. That is the surface area of this. Now if you got 1405 or 1410, something in this neighborhood used a different value, that's totally fine. I would always use this just so we're working with the same units. So that's a lesson on how to do it. There already are a couple online. You can look on YouTube to find some other ones. If you struggle with this, watch it again, watch it again, watch it again. Watch it maybe 3 times. And if you still have questions, come see me and we'll work it out, okay? But on your test, you're gonna have the surface area of these 3D shapes and the volume. And most students are doing really well with the volume, but the 3D surface area shapes are a little more challenging. Okay, watch this. Make sure you're checking in. We'll talk to y'all soon.